Dear students, we have already discussed many things in coordinate geometry. You know the vector calculus also and vector, what is the meaning of vector. Now today we are going to discuss a very important part of geometry, that is three-dimensional geometry. So as we know, three-dimensional geometry involve the mathematics of shape in 3D. So we are familiar with the various shapes in 3D, which is called the 3D space, and involve three coordinate axes. Earlier, we know only XY plane or YZ plane and ZX plane, but now we are going to discuss XYZ plane, where you can say this plane is have the three coordinates: X coordinate, Y coordinate, and Z coordinate. So let us look what is the meaning of three-dimensional geometry. Now you know and you have gone through the various shape and sizes. That if you want to visualize the correct meaning dimension of x, y, z, then this picture will help you to visualize for visualization of x, y, and z. So you can look all the faces of this cube and this x, y, and z. Okay, so if you suppose this cuboid here, and then it is very quite visible, this point x1 y1 z1, and if q is the point of x2 y2 z2, then you can see how many edges, how many faces are there. So it means in 3D we have to remember face, we have to remember edge, and we have to remember the vertex. Okay, so these are the various 3D shapes which you always look around you, and the mathematics related with the various shape also you know from your school level. And now we are going to discuss something more. Why it is required? Because why 3D? Because many jobs in the real world of work deal with using three-dimensional figures on two-dimensional surfaces. Okay, a very good example of this is the architect use drawing to show what the exterior of building will look like. So if you look any building, then you will find that the particular building is the very good assembly of the building is the collection of various mathematical shape and sizes. Every kind of the shape, mathematical shape, you can visualize during the construction of any building. Three-dimensional figure have faces, edges, and vertices. A face is a flat surface, and edge is where two faces meet, and vertex is where three or more edges meet. The volume, as you know, volume measured in cubic units. Now various example you can see here कि each of these lines is called the edges. जैसे lines हैं, इन्हीं को क्या कहते हैं? Edges कहते हैं. Okay, this corner is called a vertex. This is the vertex. This is the vertex. This surface is called a face. So this is the face, and this is vertex, and this is called edges. Okay, so now you can visualize other figures if you are having around you. We are going to make a three-dimensional figure using log blocks. So from log blocks you can make the 3D figures also. Okay, so now let us come the mathematical part related with 3D. So first of all, we have to study about the direction cosine and direction ratios. The direction cosine of a line are the cosines of the angles which the line makes with the positive direction of the coordinate axis. So already you can say if this is the x, y, and z axis, then you know this is, if this is the line OL, then this makes with alpha. Here the y axis make beta and z axis make gamma. So consider a line OL as shown, passing through the origin O. Let OL be inclined at angle alpha, beta, gamma to the coordinate axis. Then in that case the direction cosine are given by L is equal to cosine alpha, M is equal to cosine beta, and N is equal to cosine gamma. We know that for the line LO means the directed line segment in the direction opposite to OL, and the direction cosine will be minus L, minus M, and minus N. So if the direction change, then the direction cosine will be changed by negative sign. The direction cosine for a directed line L not passing through the origin are the same as the direction cosine of the directed line parallel to L and passing through the origin. So in this case, both are the same. We can also remember that for any point P laying on the line OL with direction cosine LMN such that OP is equal to R, the coordinate of P as shown in the figure may be LR, Y is MR and Z is equal to NR. It means any point will be LR, MR and NR where OP is R, and you know this square x square plus y square plus z square means this whole square is equal to R square. Now from here we will have one equation, L square plus R square plus M square is 1. The direction cosine of any line will certainly satisfy this relation. Now you can see the problems related with direction cosine. There are various problems and we can calculate how if the direction cosine of a line passing through the given points P and Q, where the coordinate of P is x1, y1, z1, coordinate of Q is x2, y2, z2, then we can write this x2 minus x1 divided by under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square and so on. Similarly, the direction ratio of the line segment joining both the point P and Q may be written as x2 minus x1, y2 minus y1, z2 minus z1, or we can say x1 minus x2, y1 minus y2 and z1 minus z2. For example, if you look, you find the direction cosine of the line passing through the 2 points minus 2, 4, minus 5 and 1, 2, 3, then we can find out by using this formula. We know that x2 minus x1, y2 minus y1, z2 minus z1, and direct cosine we may also define like this: x2 minus x1 by pq, y2 minus y1 by pq, and z2 minus z1 by pq, where pq you can calculate. Then p and q are there, and after putting this value, we may be in position to write the direction ratios, which will be 3 minus 2, 8, and direct cosine will be 3 by under root 77, minus 2 by root 77, and 8 by root 77. Now, for example, for practice, we can do some problems, and we will discuss some more problems with more formula in the next this next video lecture. Please do subscribe and like this video. Thank you very much. Thank you.